Okay, so here is a good exercise. It's good that you work on that by yourself. I'm going to go through that, but I want you to stop the, after I read it, stop it and work on yourself, work on it by yourself, and then come back and look at what I have to, like, look at my answer. So what it says in this video, it says that involves the normal distribution, typical process specs example. In an industrial process, the property of a, let's say, sample something, is considered important. The buyer sets a specification on the property to be 3 plus minus 0.01 with some appropriate units. The implication is that no part outside of this range will be accepted. It is known that, so it comes from the catalog, right? It is known that in the process, in the question, the property follows a normal distribution with mu equal to 3 and sigma equal to 0.05. How did we find this? Because we said that here is 3, right? So this 3 tells us that we are looking for the mu is going to be 3. On the average, so this unit is going to be the same as this unit, right? Appropriate unit means that it's going to be like this. On the average, what is the percentage of product to be scrapped given the production aspects? As I said before, looking at the rest of this video right now, please try to solve it by yourself. Read it by yourself and solve it, and then come back and read the look at the rest of it. Okay, so now let's look at the solution to see that what do we have. We have the information. The information that we have is this. The from the specifications, we have 3 plus minus 0.01. Out of this range is going to be scrapped. And in the question, we want to know on the average, what is the percentage of products to be scrapped, right? And then we know that mu is equal to 3 from the historical data. You can see it from here as well. But for the sigma, we need the historical data. So the sigma is going to be 0.005. So what are we going to do is that we are interested to find out the probability of the x between, because here is that 3 plus minus 0.01. So it means that if x is less than 3.01 and greater than 2.99, right? The negative and positive of this one, then we can accept the product. If not, it's going to be a scrap. So let's find out the probability of having x between these two numbers. Then we can say that, okay, so whatever is outside that range, outside that number, so 1 minus whatever, so we would say it's going to be the scrap. So we are looking for the probability. So this 2.99 and 3.01, we want to convert it to the z word. So what are we going to do is like that. So here we would say z for this one. I'm going to call it z1, for example. It's equal to the x1 minus mu divided by sigma. X1 is 2.99 minus mu is 3 divided by sigma is 0.005. So we are going to find out minus 2. So this is going to be the lower bound for our acceptance. We are going to do the same things for the upper bound, 3.01, and we're going to find out plus 2. Then, so we would say this PR is the probability. Sometimes I use P, sometimes I use PR. Both are like, it's like proportion, because here we are talking about the proportion for the probability. So I would consider it, I would write down PR, but both are acceptable. You can use any of those that you want. Some books they use, like Montgomery books, they have different authors, right, for the stats that we use it as our reference. And Montgomery, the way that it uses different than the symbols that we would have in, like, for example, Johnson book. So so it's up to you, as long as it's so, if you write down PR, I would know that, but so that's fine, as long as your procedure is correct. So we find out the upper bound and lower bound. So we're looking for the probability of z between minus 2 and plus 2. So the next thing that we want to do is that we want to go to the table and find out the amount of the probability between them. Before going there, let me show you what's happening here. So this is my curve, normal distribution curve. We said that the center, and let's say this is z table, right? And here is the probability. The area under the curve is going to be the probability. The center is 0. We said that the expected value of z is going to be 0. The mu is 0 for z. And then we are looking for what's going to be the probability between -2 and +2. So we are interested to find out this value. Right? The only thing is that, and it shouldn't be skewed, it's just that my painting is not that much good at drawing. Okay. So we want to go to the table and read the what's the value at -2 and +2. Be careful here. When you read from the table, it's cumulative from -infinity. So when I go to the table and read the value for the z at -2, in fact, I'm gonna find out the value for this area. So from table, you find this area. This one is the value you would read from table. Z table. So it's like that from Z table, you cannot find out what's after that. Like for example, if I want to find out +2, I'm gonna read the whole value, like from here to here. So what should we do is that we are going to read the value of the, for example, there are different methods right now. It's like that you can read the z at less than -2. And then we would say the whole area under the curve, we learned that before, is going to be 1. So we would say 1 minus this value, whatever it is going to be the whole area after that. And then we can do the same for this one as well. Like for example, it depends on how would you want to go with it. One thing that you can do, you can read the z value at 2, right? Like before 2. And then you can find out the z value before -2, and then you can subtract them, and you're going to find out this one. Or we know that the normal distribution curve is symmetric. What can you do is that after you found out this one, you can say, okay, this value is the same as this value. So you will double this, and you will say 1 minus the double amount of this one is going to give you this amount. So when we do that, we are going to find out 0.9544. So this area is 0.9544. It means that it's 95%, 0.44, right? So this, but we are looking for the scrapped one. This is the acceptance range, right? So for the scrapped one, we would say 1 minus this, 4.56. This is the amount that is going to be scrapped. So in the question, we have been asked that on the average, what is the percentage of the product to be scrapped? We would say it's the 4%, 4.5. It's a lot, right? So 4.5. So this is designed like the product. We need to play with the mu and the sigma, or we need to play, in fact, with the sigma. We need to reduce the amount of the variance. Because this 4% is a lot, like 4%, just think about it. If you have 1 million product per day, how many of them is going to be scrapped? So it means that you're losing money for that ones.